Ich bin Mathieu. Ich arbeite bei Microsoft. And I will continue in English. This is all the German I know for now. So I work in the Flatcar team. So Flatcar is an operating system, community-driven and open source, which is designed to run container workloads. On this operating system, I mainly work on package upgrades, testing the operating system, and also trying to have SE Linux in shape in the operating system. And in my civilian life, I volunteer with two associations, Engineers Without No Borders and DevOps France, which is an association where we organize DevOps event in France. Okay, so provisioning. This is the first time I put Walnut in a slide presentation. So provisioning, what is it? I was not sure about the level of each attendees to this event, so we can try to get things a step back on it. And let's see what is it. So let's suppose you want to deploy your website. Let's suppose you want to deploy some workloads. So you first need to deploy an infrastructure. So you can use Terraform. This is the most common way today to deploy stuff. You can use your shell scripts. You can use whatever you want. But in the end, you have the same result. You have an empty shell. So you have servers, but they have no soul. There is nothing deployed on it. There is no business logic inside. So you have your server to deploy your web server, but now you need to do the actual provisioning. So provisioning is to feed the shell, is to give the business logic, is to be able to provide all the things you need to run your workloads inside this infrastructure. So this is how I tend to explain the provisioning to my friends and to teammates when we have to talk about that. So basically, you deploy an empty shell, and with provisioning, you try to fill that shell. So this talk is about Ignition, and it's a one-time provisioning software. Of course, there is plenty of other tools to provision your infrastructure and your instances. The goal of this talk is to not say that Ignition is the best or other things. It's just to give you an example of another tools. And this is what I like with open source is, as user, we have a choice in the tools we want to use. And Ignition is one of tools to do provisioning. So you have also Ansible, you have Cloud Init, you have Chef, Puppet, stuff like that. But the idea is just to show another example of provisioning with Ignition. So Ignition is a one-time provisioning software. So what does it mean? It means first we need to define what we want to do in our provisioning. So for keeping the things simple, in that example, I want to deploy on my server. I want to deploy a web server which is going to serve a simple logo, simple image, and a simple text just to say hello FrOSCon. So this is really a hello world in terms of DevOps stuff. Ignition, it's declarative. What does it mean? It means you just define what you want to do, what's the final state you want to reach on the instance. So there is no dynamic stuff like you can see with Ansible, where you are going to define condition, statement, and take actions in following the output of these conditions. So with Ignition, it's like, I don't know, XML or stuff like that. You just define the states, and this is what you want to reach into your final instance. So in that case, I say that I need to define a web server. So I'm going to use KD because it's the easiest. And I need to get a user KD, which is able to run Docker containers. So I put it in the Docker group, and so on and so on. And I need to get my source code. So it's index.html. I need to get my logo, and so on. So this is all the stuff I need to do to run my web server. So first rule, Ignition is declarative. Ignition is made by computer scientists. So it's like computer, it's binary. With Ignition, you don't have an half-state provisioned instance. It means if your provisioning is failing, your instance won't boot. That's it. There is no other choice. It won't boot. But if it boots, it means provisioning has successfully been done. So this is quite cool. You don't need to run after script to check that your Ansible has run correctly or rerun once again your non-idempotent Ansible. So with Ignition, it's all or nothing. So we can see an example. With the KDE web server I mentioned. So this is an extract of my Ignition configuration file. So I talked about a logo earlier. So this is the URL of the logo, but you can see that a G is missing at the end of the file. So it's SV instead of SVG. So basically it's 404 if I try to fetch this resource. So now I'm going to boot a server using this Ignition configuration. So we can see all the systemd stuff, the kernel stuff, and so on. And boom, there is nothing. It froze. It froze because there is an issue. And it shows critical error. You landing in the emergency shell, so it's quite annoying. But if you scroll up, you should be able to find the actual error. And there is a resource not found because the SVG resource not found, we can see it. Failed to create file, resource not found, because the URL is the bad one. So if you fix it, you'll be able to boot. So it can be a bit frustrating, a bit disappointing to have this, but in the end, it's better to have an instance that boots in the correct state than being in a half state, and you need to check that things are correct. Let's get back to the presentation. And this is the third point of Ignition, which is a bit tricky to understand. It runs only once. So once your instance is provisioning, Ignition won't run anymore. In the opposite of Cloud Init. For example, Cloud Init is going to run at each boot. With Ignition, it runs once, and if it successfully booted the instance and provisioned the instance, you won't hear anymore about Ignition. So this is a bit tricky to understand because sometimes we have issues on Flatcar repository that users do not understand why their instance do not change. If they change the Ignition configuration, it's because it runs once. So you can do whatever you want in your Ignition configuration. If you still try to boot the very same instance, it won't run because it already ran. So we can see this in action. So I fixed my SVG error. So now I can boot the instance, and it should boot correctly. So if you've been quick, you've seen a couple of lines regarding Ignition and the systemd unit that is being created to run the web server, the user KD which is created, and so on and so on. So now I'm on the instance that has boot, and I can check that my FrOSCon demo web server unit is working fine, and I can try to curl my web server. So I see that there is the hello FrOSCon. So now I can shut down the instance and try to slightly change my configuration. So I said I change FrOSCon by world to be original. And now I reboot again the instance. I pass it the Ignition configuration file. OK. I can check that my web server is still working fine. And if I try to curl, oh, it's still FrOSCon, but I changed my configuration to hello world, and it's still hello FrOSCon. This is weird, no? No, this is how Ignition works. It runs only once if it boots successfully. So we got this morning this talk from Thilo about Flatcar and ignition and provisioning with Ansible. So what can I do if I want to provision my instance? It means I need to destroy it and to recreate it. So it's a bit tricky to understand and to put that into production, because it means you need to kill instances, to reboot new instances, or to flush the root file system. But this is the idea that the nodes in your infrastructure, the servers in your infrastructure should be stateless, and you should be able to wipe it and to remove it if you need to. So this is ignition. It runs only once, and ignition can be generated. So it could be, must be generated, because you might see that ignition is a JSON configuration file. Who wants to write JSON by hand? And it's prone to error a lot, because ignition can be, JSON can be quite complicated with all the indentations and all the brackets and stuff like that. So it's recommended to generate ignition configuration. So there is two tools to do that. One is called Container Linux config, and the other one is called Butane. So it's just tools that transpile YAML configuration file to ignition configuration file. It's not only converting YAML to JSON, otherwise it's too simple. With Butane, for example, you can add some sugar in your ignition configuration, which means if your instance, if your target operating system has some specification regarding stuff you can do or you can't do, Butane will take care of doing that. For example, with Ignition, latest version of Ignition, user is able to define LUX, encrypted LUX volume file system. And with Ignition, you can write and define your LUX stuff, define a key, define a clavis if you want to use clavis, for example. But with Flatcar, we do not yet support clavis. So with Butane, we prevent users to use clavis into the ignition configuration. So like so, there is no bad surprise in production. Like, okay, why doesn't work? So previously, we prevent something to happen with Butane. And also, as a sysadmin, DevOps, and others, we like to write YAML. And yeah, it's easier. It can be it's easier to read in pull request or others. But yeah, this is the idea with Butane. And we tend to promote Butane instead of Container Linux configuration, because CLC is a bit deprecated now, and it would be nice yet to have all the documentation of Flatcar using Butane. This is another way to generate stuff. So in my Butane configuration, I define a file system from a device which is going to be mounted somewhere. And I can specify with mount unit Boolean. And when I'm going to transpile this YAML configuration to Ignition, it's going to automatically generate systemd mount unit. So you don't need to write this whole unit. It's automatically generated by Butane. And this is quite handy because it allows you to have a smaller configuration in your Butane definition. And everything will be generated to Ignition in the end. And you have all the required dependencies to the systemd unit. And the only difference is that you get generated by Butane command. So like so, if someone wants to SSH into the instance and inspect this mount systemd unit, he will find that it's being generated by Butane. So it's Butane to blame if there is an issue. Okay, so nice. You shown me example with QEMU and local examples. Now, how does it work at scale with bigger infrastructure or with cloud providers? So Ignition, in the way it's developed, implement a couple of ways to fetch the Ignition configuration. So you might see that locally, I can just run my QEMU local instance and just provide ignition configuration file, so it's really file local. With cloud provider, I can easily use the metadata server. So for example, with AWS or Azure, we are able to use IMDS, so instance metadata server, where you can find the IP, the SSH keys, over useful information, and you can also upload configuration, ignition configuration. So like so, when the instance is booting in the cloud provider, it's going to fetch the metadata server, get the configuration back, and boot the instance using this configuration. So this is quite handy, and this is an example with Azure. On Azure, there is a user data field, so you can use Cloud Init or, for example, Ignition. It works fine. On AWS, it does support IMDS v1 and v2. And on Azure, it supports user data, but also custom data. And for other cloud provider like OpenStack, it supports the regular metadata server. And you can also use kernel command line parameters. For example, for VMware users, you can use the guest info parameters command line. And like so, you define your ignition configuration in base 64 inside this parameter, and VMware instance will be able to fetch the configuration from this kernel command line parameters. So regarding the spec sheet of Ignition, there is a version defined on top of the configuration. So as many useful tools, Ignition is versioned. So you can't do stuff in Ignition v2, and you won't be able to do that in v3 and in v1, for example. So this is pretty useful because you can just pinpoint your Ignition configuration, and you're sure that every time it's going to be read into that specific version. But it also brings this the issue we have everywhere in computer science about the compatibility between major versions. So between v1 and v2, it's breaking changes. Between v2 and v3, it's breaking changes. So the idea is that if you want to port your Ignition spec from v1 to v2, you have to rewrite stuff, and same from v2 to v3. Rewrite, and for example, with v2, you can define networkd systemd unit directly into the Ignition configuration, but in v3, you can't use a networkd keyword. You need to define it as a regular file system. As a regular file, sorry. So this on the Flatcar side, we started to look into this version 3 Ignition topic because we wanted to be up to date with the upstream, to bring more secure software, and also to be up to date with what's going on with current container OS ecosystem. So we wanted to be able to use v3 into the operating system, but we wanted to preserve users in v2 to have some breaking changes and to not be able to use the Ignition configuration file anymore. So the idea with Flatcar in general is to break the less of stuff. So we try to be from one version to the other to be seamless in terms of update. So you can just focus on your workload, on what's deployed on the instance rather than administrating your server. So we tried to find a way to support v1, v2, and v3 at the same time, at the runtime. So we come up with this implementation. So basically, the user wants to boot the instance with Ignition version 2.4.0. Inside Flatcar, inside the Ignition binary, it's going to check its version 3, yes or no, and it's going to translate version 2 to version 3. So it's a bit intrusive for the end users because he's going to have his ignition configuration translated on the fly. But in the end, it ensures seamless transition for ignition to ignition 2 to ignition 3. And if it's version 3, we just do nothing and we proceed as usual. So this particular implementation makes that ignition on Flatcar is drifting from the upstream. So ignition is developed initially by CoreOS folks, and we try to be as much close as possible to the upstream work, but as you can see, this is very specific to Flatcar because we want to ensure compatibility between V2 and V3. So on the Flatcar side, we are carrying a couple of patches, so 15, and most of them are used to ensure the translation between V2 and V3 and to ensure stuff like loading the ignition configuration from the OEM partition, and also, yeah, mainly that, and also some naming convention. For example, if you want to use a remote configuration, you can use the kernel command line parameters called ignition.config.data.url, if I recall correctly. And with these patches, we can use a CoreOS or Flatcar name in the kernel command line parameters. So always in the same idea of do not break things between updates. And the cool thing around that is that we have a bunch of back and forth and a bunch of discussions with the upstream, because in the open source world, we try to help each other. And so these 15 patches needs to stay in the Flatcar, but we got 10 or 15 other patches that has been merged into the upstream because it's helpful for the CoreOS users also. And so yeah, there is a really good collaboration between the two projects and between the upstream and the downstream. So we still need to maintain these patches. So each time there is a new ignition release, we need to try to backport all these patches, but it's quite correct. It's only a couple of 1 hour or 2 hours if everything is going fine to update the patches. So yeah. Now ignition itself, how does it work? So let's talk about a bit more what's going on the stage, because we talk about the way to declare stuff, the way to define configuration and to generate with butane, but now how does it work in the system itself? So first it runs in the initram file system. So it's pretty cool because it runs really, really early in the boot, and you can, so you have some flexibility on it. For example, you can use kernel arguments. In your configuration, you can define a couple of more of kernel arguments you want to have in during your boot. So, for example, if you want to boot the instance with quiet kernel command line parameters, you can define in your ignition configuration, okay, this kernel command line parameter should exist. And in the initramfs is going to check the /proc/command line. Is there this quiet command line parameters? If yes, does nothing. If no, it appends to it and it reboots the instance. But since it's quite early in the initram file system, you almost not notified that the instance actually reboots to append these kernel arguments. So it runs in the initramfs, so you have some other consideration to take into account. For example, ignition relies on system dependencies on binary. There is a few places in the code base of ignition where it actually calls existing binary. For example, if you want to reliable your whole system with SE Linux, you need to get this set files binary. So it has to be in the initram file system. So if you are a distro maintainer, you need to build your initram file system with set files. Another example, with if you want to I don't remember other example. Yeah, I think there is some with make file system command also. You need to have it into your initram file system if you want to be able to flush partition or stuff like that. But yeah, as a distro maintainer, this is quite interesting to know that if you want to provide ignition to the users, you need to provide the correct tools inside the initram file system. So I know that ignition is also packaged by Debian. So if you want to try with Debian, you can, but I would not recommend to do that on your personal workstation. But you can try it in a server, and you should be able to find in the initram file system the required tools to actually use ignition. So this is how ignition works in the initram file system. So it relies on external dependency, but there is not so much, only, as I said, a couple of binaries that needs to be here. Crypt setup has to be here also if you want to play with Lux encryption. Crypt setup needs to be in the initram file system. And yeah, also ignition is developed in Go. So it's only one binary in the end. There is not bunch of dependencies like you can see with Ansible and Python. So it's only one single binary that can run, and it's not really, it's quite light, so it can easily fit into the initram file system. And the workflow, what's going on when the instance is booting, it's going to go through some stages. So each of the stages needs to be run in that specific order. And if one of the stages is failing, it just abort. So end of the mission. If one of the stages is failing, we just land into the emergency shell, like you've seen at the beginning of this talk. The fetch online and the fetch step are just the beginning of everything. We just need to find ignition configuration, because it's nice to boot the instance, but if there is no configuration for ignition, ignition does nothing. So it has to fetch it. So it can be fetched from the kernel command line parameters, it can be fetched from the instance metadata server in cloud providers, as I said earlier. So yeah, it just tried to grab this configuration. And after that, it read the configuration, and it goes through all the steps. So first he checks for kernel arguments. As soon as we know that we need that specific or that we don't need that specific kernel arguments, we reboot the instance. Then we go to the disk step, the mount, and the files. So this is where we can make our file systems, define partition, mount stuff on the system, and we can also write a systemd unit. We can write a file into /etc. Anything you need to provision your instance, it's done in the disk mount file stages. And each of these stages can be easily debugged. So if you land into the emergency shell, you can easily get the status, because in the end it's initially ignition, it's a systemd generator. I mean on Flatcar it runs in this way, systemd generator. But each of the steps are actually unit files, so you can easily debug with journalctl and systemctl in the emergency shell. If you successfully boot the instance, you won't be able to see again this, because it was in the initram file system. So, and if you successfully boot the instance, you don't need to debug it anyway. So yeah, that's it for the workflow. So I'd like to kudos to folks that initially deployed this super software. So Benjamin Gilbert, which is working at Fedora CoreOS. He was initially in the CoreOS team, and CoreOS after became Flatcar. So all these pieces together, and also the Flatcar alpha and beta users, because this is people that try to test and to canary deploy the Flatcar instance and to raise any issues we got with this ignition configuration and this ignition work. So yeah, And one last word regarding Ignition code base. So it's totally open source and it's in Go. Contributions are more than welcome. It can be documentation, it can be bug fixing, it can be new feature implementation. So Ignition and Butane are open source and contribution are welcome. And the code base is quite nice to work in. It's well architectured, and you'll see common code base and also various implementation following various providers that support Ignition. So Azure, AWS, GCP, OpenStack, bare metal also. It boots on bare metal. So yeah, I think that's it for me. Thanks for your attention. If you have any questions, please feel free to ask. I'll be around today and tomorrow, so yeah, with pleasure we can have a chat. Danke. Okay, so maybe there is a mic.
So you said it's already on, yeah? Okay. So maybe you said Ignition is purely declarative, but as I understood Butane, you just put all the dependencies, you refactored out the dependencies. So in the end, when you read the Ignition file, that's declarative, isn't it?
Yeah.
Magic here?
So there is, in the end, Ignition is fully declarative. You won't get any custom logic inside. Butane is trying to implement that custom logic. Like I said, with Flatcar, we do not support Clevis, for example. So Butane is just going to say, stop, I won't generate that Ignition because Flatcar does not support. But it's like a firewall to prevent users to write stuff that are not supported by Ignition. If you need to add custom logic, dynamic stuff into your configuration, you can just use systemd unit. And once the instance will be booted, it will do the things, but won't in the runtime, during the runtime, not during the provisioning. So this is why some users prefer to go with Ansible or Cloud Init, because you have more flexibility. But in the end, it's just a choice to do. Do you want to get something fully declarative, or do you want to get some custom logic and dynamic stuff, but it can be really spaghetti stuff in the end because there is calls in every sense.
Okay, thank you.
Thank you.
Thank you for the nice talk and the nice introduction. I just want to confirm that I got this right. So Ignition is basically just for Flatcar. It cannot be used for other distributions, right?
So this is what I talk about with Debian, for example. There is a package of Ignition supported by Debian. I'm not sure yet what's the status on this package, if it works or not. This is why I suggested to use not your workstation if you want to try out. But yeah, the idea is that it's not bound to one operating system. It's at least as long as you have the requirements in the initram file system, set files and also other stuff, and yeah, that's it. At least that you have the requirements and Ignition into the initram file system, and maybe a couple of other stuff. But this is the two main requirements. That should be alright. So it currently works with Flatcar, with Fedora CoreOS. And also, if I recall correctly, with Garden Linux on the with the Pixie features. So at least there is this free known operating system, but I'm pretty sure that you can find other examples, but yeah, it's not bound to an operating system. You can definitely try to use it with another one.
Is there something special that you have to do to disable those patches that you mentioned? Because those patches seem to be bound to Flatcar, right?
So if you check out the GitHub repository of Ignition, you won't get those patches. Those patches are injected at build time of Flatcar, because Flatcar is based on Gen 2 Linux, and everything is built from sources, so we can easily inject our patches at this time. So on the upstream side, there is only the useful patches for the community and also the core development of Ignition, but you won't find any custom Flatcar patches upstream. They're just inside our repository during the build of Flatcar. And even in the Gen 2 e-build definition of Ignition, we are using the release from the upstream. And it's just after downloading the release that we apply the 15 patches, and then we build, and that's it.
Okay, and the final question is, because you mentioned Cloud Init a couple of times, what exactly is the relationship between those two? Because they seem to serve similar purposes.
Yeah. So, as I said, the idea is to give you another overview of another tools. Cloud Init does provisioning of instances, so it's the same thing as Ignition, but it has some slight differences. For example, Cloud Init will run at each boot. So every time you're going to boot the instance, Cloud Init will run. So it's okay, but if your configuration is not idempotent, so it's going to apply again and again and again, and it can lead to issue. But once again, it's up to the user, actually. If it's fine having something running at each boot, okay? But with Ignition, you're just sure that, okay, it boots once, it runs, it's success, and I can forget about the provisioning, because anytime the instance will boot, it's already provisioning. So if I want to deploy Docker container and they can run through systemd unit, and that systemd unit is enabled at boot, so it means I can safely reboot the instance and everything will just go back in place. And also this part can be really useful when you use an OS with rolling update, with like Flatcar, for example. You won't get a new version like Ubuntu and 20 to 22, stuff like that. With Flatcars, each month you get a new release, and it's just downloaded on partition. And when you reboot the Flatcar instance, is going to switch the partition to use the new one with the new version. So you don't even need to reprovision the instance, because it just changed the user partition. But yeah, so Cloud Init, Ignition, same thing. You can also try to use Ignition in complement of Ansible. For example, if you have really deep custom stuff that you can't do with Ignition, you can use Ignition and Ansible in the same instance.
So would the typical kind of setup would involve Ignition for the, let's say, the low-level stuff, and then you would use Ansible for deploying everything else? Yeah?
For example, you can think about deploying SSH keys with Ignition, and then with Ansible, you just remote connection on it and do your stuff. But for example, that could be a use case to deploy or to create a user, or as I said, for example, with the kernel arguments, you can't do that with Ansible. Or you can do, but it means the instance already booted until the end, then you need to reboot to inject. So since with Ignition, it's kernel arguments in the initramfs file system, it's okay, you don't lose so much time.
Hi, first of all, thank you so much for your talk. I think you just touched on this with the previous questions from the two people, but is there any extensibility to Ignition? Could I, for example, the same way I write an Ansible role, extend Ignition's functionality?
So I would say that if you want to bring more functionality to Ignition, just fill an issue on GitHub and ask to the core teams what they think about that. And I'm pretty sure they come up with a solution, a good solution to your use case, specific use case. Or maybe they will just find that your ID is great and that should be implemented into Ignition. Do you have something in mind in particular?
No, just a general question.
Okay, so yeah, with Ignition, if you take a look to the spec sheet, there is not so much field that you can fill into the specification. You can define users, you can define file on the file system, you can define partitions, systemd unit, and LUKS encryption, and yeah, that's it. So this is really the basis for a sysadmin to configure an instance. And all the application side, if you want to deploy application side, it's most of the time, at least for the Ignition users I know, it's most of the time deploy Docker containers with systemd unit. So, for example, these web servers can easily run into a Docker container with a systemd unit. So you just need to define all this into the... But yeah, if you have legacy applications with a bunch of dependencies, maybe it's easier to use Ignition and Ansible. And like so you have a smooth transition, so you can directly start to play with Ignition, and in the end you can try to migrate all your custom logic from Ansible to Ignition.
Thank you.
Thank you. Okay, so thanks again everyone, and if you have any question, I'll be around for the next days.